Hello again. This is new problem, P876. So we'll start this out by looking at the numbers like I always do. I've got 26 inches of vacuum, which is a useless number. I have to convert that, and I have 100 degrees Fahrenheit, which I may have to turn into degrees Rankine, but we'll see. So 26 inches of vacuum. Alright, so I got that. Which of the following is the approximate condensate subcooling in a steam condenser operating at 26 inches vacuum with a condensate temperature of 100 degrees Fahrenheit? Okay, so looking for a condensate depression, but calling it condensate subcooling. I like it. So what does 26 inches vacuum mean? Well, again, when we start up here at atmospheric, here's the line to atmospheric. Here is 0. So what they're saying is that your vacuum is 26 inches deep. And as we know, 1 atmosphere is equal to 29.94 inches of mercury, and 1 atmosphere is also 15 psia. Okay, so we're looking for this distance right here. That's what we can use as the conditions inside of our condenser. Right? We call that back pressure in the business. So pressure of the condenser is going to be equal to 29.94 minus 26. That's going to be inches of mercury. So you can either say 3.94 inches of mercury is about 2 pounds, or you could do it the slow and painful way. So I'll do it the slow and painful way since I'm working these problems out for you guys. So we got to change inches of mercury to atmospheres, and then atmospheres to pounds per square inch absolute. So I'm going to say that 29.94 inches of mercury is going to equal to 1 atmosphere. And I also know that 1 atmosphere is going to equal 15 pounds per square inch absolute. It's 14.7 pounds per square inch absolute, but this is what the NRC uses, is 15, and it's close enough. It wouldn't really matter. So P condenser is going to equal, and I'll calculate this real quick, 29.94 minus 26 times 15 divided by 29.94. I get 1.97 psia. Now it's not always okay to round up, but in this case I'm going to say it's pretty close. Alright, so these are going to be saturated conditions. Well, excuse me. These are going to be conditions inside the condenser. So what we need to do is we need to look up the saturation temperature at 2.0 psia. So get out your steam tables. I always go to table 3, the superheated steam, because it's easiest to work with, my opinion. So on page 15 you'll see that we have absolute pressure of 1 pound per square inch and absolute pressure of 5 pounds per square inch. We can still get interpolate 2 pounds, but let's try table 2. So we go to table 2, that's page 11, and that should give us the saturated steam for each pressure. And I see 0.1, 1 pound to 10 pounds. Alright, so we're no joy on that. So we may have to interpolate, but I kind of doubt it, because if you go to table 1, you'll be able to go to page 5 and look at the second column for absolute pressure, and that'll have a corresponding saturation temperature. So it starts out at 0.08 pounds per square inch absolute. Now we're going down, and look here on page 6 at about 126 degrees you have a saturation pressure of 1.9985. So that's what I'm going to call it. I'm going to call saturation temperature at 2 pounds 126 degrees Fahrenheit. Okay. So what's happening here inside this condenser is, if we use an entropy diagram with a saturation curve, what's happening is along this pressure line, that's going to be pressure of the condenser. It's going to be 2 pounds. Exhaust steam is coming in from the turbine at this entropy. It's going down here and going into the subcooled line, and then going to the saturated line and then becoming slightly subcooled, because it is coming in at 100 degrees. So not only is it turning into water, saturated water, but the condenser's taking a little more heat out of it. And that heat is subcooling. And that's going to be the difference between saturation temperature at 2.0 psia minus the temperature of the condensate. And subcooling is going to be equal to 126 minus 100. It's going to be in degrees Fahrenheit, or 26 degrees Fahrenheit. So let's see if we have that for an answer. No, but we have 25, so it's not very close to 19, although that is pretty close. It's not 2 and it's not 53, that's for sure. So I'm going to say 25 is close enough for government work. Okay. That's question ID P876. And that is about all I have to say to you people. Thank you.